What's up, guys, and welcome to this tutorial. Okay, so we're going to basically be going over question 9, photons and electrons of the 2018 supplementary exam. Okay, so this is the last question. Okay, so it says ultraviolet light of a given frequency is shone onto a metal surface. The work function of the metal is this, and electrons are ejected from the metal. Okay, so it says question 9.1.1. Calculate the energy of a photon of ultraviolet light. Okay, so simple question. So using our formula sheet, we know that E is equal to H times F. H is obviously Planck's constant. So it's equal to 6,6 times 10 to the minus 34 times our value of F, which is 9,1 times 10 to the 14. Okay, and the answer we get is 6,01 times 10 to the 19, or minus 19. Okay, and the units of energy is joules. Okay, so that's the first question done, and we get ourselves 3 marks. Okay, the next question is a freebie as well. It is a definition. Okay, so define the work function. Okay, so work function is the minimum amount of energy needed to emit an electron from the surface of a metal. Okay, then so we get 2 marks. Okay, 9.1.3. Okay, calculate the maximum velocity of the ejected electrons. Okay, so we've already calculated the energy, the total energy, but we also know that E is equal to our W naught plus EK max. Okay, and we obviously want to know the velocity. Okay, the maximum velocity. Okay, so we know what the work function is as well. So we have okay, so E is 6,01 times 10 to the minus 19 is equal to 3.5 times 10 to the minus 19 plus EK is going to be a half times the mass of an electron, which is equal to 9,1 times 10 to the minus 31 from our formula sheet. So it's equal to a half mv squared. So we have v squared. Okay, and the only unknown in this equation is v squared. So carrying out the calculation, we get that v is equal to 7,43 times 10 to the 5 meters per second. Okay, and that's the answer. Okay, and we get ourselves 4 marks for that. Okay, cool stuff. Then it says question 9.2.1. Okay, so light of a wavelength light of a wavelength of 524 nanometers is emitted from a certain element when an electron transmission occurs between the 5th and the 2nd energy levels. Okay, so describe a photon. Okay, so that's also kind of like a definition. So a photon is a particle of light. Okay, so looking at question 9.2.2, calculate the energy of the photon of light that is emitted. Okay, so we know that energy from our formula sheet is equal to hc over lambda, where h, okay, obviously we're doing this because we know what lambda or the wavelength is, because that is given. Okay, so h again is Planck's constant, which is 6,6 times 10 to the minus 34. C is the speed of light, which is 3 times 10 to the 8, and our lambda is 524 times 10 to the minus 9, because this is in nanometers. Nano is 10 to the minus 9. Okay, so the answer to this E is equal to 3,78 times 10 to the minus 19 units of joules. And that's that answer. Okay. Then it says the second energy level has an energy of minus 2.81 electron volts. Calculate the energy of an electron in the fifth orbital. Okay, so 9.2.3. Okay, so this we can say that first we know what the energy is, or the energy that's emitted is what we calculated before, but we need this in electron volts. So we need to convert this into electron volts. So we can say that 3,7. Okay, we also know, if we go look at the formula sheet, we know that 1 electron volt is equal to 1.6 times 10 to the 19 joules. So 1 electron volt is equal to 1.6 times 10 to the minus 19 joules. Okay, so what we can say is, if we have 3,78 times 10 to the minus 19 joules divided by 1,6 times 10 to the minus 19 joules is equal to our electron volts, which is equal to 2,36 electron volts. Okay, so now we know what the value of our energy is in terms of electron volts. Okay, so now what we can say is that E5 minus E2, so getting emitted from 5 to 2, is equal to our total energy. Okay, we know what E2 is, so we know that E5 is going to be equal to E2 plus E, which is equal to, E2 has a value of minus 2,81 plus 2,36. So therefore E5 is equal to minus 0,45 electron volts. Okay. Yeah, and that's the final answer. And if we wanted to, we could convert to joules again, but we're going to leave that answer in electron volts because we've been given everything in terms of electron volts. Yeah, so that's that question. Not too difficult, quite easy, straightforward stuff. So yeah, I hope you guys found that useful, and thanks for watching.